Hello everyone and welcome to Geonodes daily series where we do something cool in geometry nodes and we try to do it as fast as possible. And today we will see how we can use the extrude nodes and scale elements nodes to create this stylized city. And actually we will get to see two methods to create this type of effect. Of course, you can apply it to something less stylized, something more realistic if you want. The technique will be the same. It's just about adding more details. So we will follow these steps that you see in this card, and we will recreate the most interesting part of the project, the geometry node setup. For the materials, you can check the video in the description or the one that appeared during the demo. As usual, before we start, I would like to give a big thank you to all of you for supporting this channel. So thank you for subscribing, commenting, liking the videos, watching the videos, and a big thank you for those of you that decided to purchase the project files from Gumroad. That really helps me, and you get to play with something cool. So let's start with this. Like I said, it's an exercise of using the new Extrude node, so it's a good idea to have the latest alpha version of Blender 3.1 or beta or whatever it will be when you watch this video. So let's see how can we generate this effect. Well, we need some mesh to start with, and given that we will use extrude, let's just use a grid. And I want to do some things with this grid. I want to get the spacing between the buildings, and for that I'm going to use a geometry delete geometry node, and I'm going to switch this on to face, and now everything is gone. We can get it back in two ways. We can do, for example, a random value and switch this on to Boolean, and now as you can see, some of the faces come back. Let's put some more resolution here. So we can play now with this value to get more or less of the surface. This will be our city map, kind of. That will be one way. Or another way, you can use a texture. And actually, this is what I want to do. Take a Musgrave texture and turn it into a Boolean by using a compare node. Take this height here and say greater than is just fine. Plug this one here, and then we can play with these values any way we want. So let's say something like, maybe something like this. And now we can play with the values of this texture to get whatever. So let me put something round. You can play with these values, you'll get different effects. So now that we did this, we have our base for our setup. So let's do the buildings first. Let's use this extrude mesh, extrude mesh, plug it here. And of course we want to extrude individual pieces. And if we push it like this, you already see a result. But I would like these buildings to have a little bit of variation. So let's use a random value for that. I'm going to plug this random value into this offset. And let's say I want to have some buildings like this and some buildings like that. That's just fine. There is something else that I want to change now. I want to change the shape of these buildings. And you see, by doing an not in sync scaling, because I push it on the X, you can make the buildings wider because the square that compose them gets wider. So let me do something like maybe 1.2 here, and we get something like this right now. That's kind of nice. Let me see if I push these values around, we can get something different. Okay, excellent. So now we have a base. I want to add something on top of this building because they look squarish now. And for that, I'm going to use another extrude node. So let me plug this one here. And as you can see, we get this effect. But we can easily restrain the effect by using the top that we basically care and push it here. And then I want to, again, offset the scale. So let me plug another node here. And this time I want from nothing to something like 0.1. Excellent. It's not visible right now, unless we do something like this. But the idea is that looking in the wireframe node, we see we have a piece on top that we can basically play with. So it's time to use the scale elements node. And we can find this also in the mesh menu. And I'm gonna push this one here. And again, I want to use only the top for the selection. And now if we play with the scale, as you can see, we can affect the tip of our buildings. So why not use another random value to have different results? And I don't want pointy, so let's do something like maybe 0.3, and as a maximum 0.5, something like that. And as you can see, we already have some variation here happening to our buildings. Excellent. Now that we did this, I want to move to the second point. How can we add windows? And do that by manipulating the geometry. Let me save the file. We have to think where we want to place our buildings, our windows, and we of course want to place them on the sides, not on the top. So of course we will use an extrude mesh node again, because that's the point of this thing. And this time I'm going to use the side as a result, the side from the first extrude. So let's say something like here, and we get this result. That's not what we actually want, but let me first do some, where are you? Cavity. Okay, now we can see things better. If we extrude this inwards, so let's say minus 0.01, you get this effect. We push the geometry inside, as you can see here, and that can be a cool effect in itself, but we want to do more of that than that. In order to make this looking like windows, it will be a good idea to subdivide this mesh. So let's do that. Mesh, subdivide mesh, push this one here, and as you can see, we start to get a result that is different from what we had earlier. So let's say something like this. And as you can see, the subdivision is working nicely. But I want to add to this mask because right now everything is indented, and that can be a very good effect. You can do a lot of cool stuff with that. But I want to show you how you can mask part of this. So let's add something to this mask to restrict the effect to only parts of this geometry. Okay. One more thing that I want to add here. Let's take the normal, and I'm gonna put an offset on the normals here. Okay, great. In this case, it doesn't make any change, but that can be helpful, pushing things along the normals. Anyway, I want to add something to this mask, so let's do a Boolean math and say and. So if this condition is true and another condition is true, then we get our selection. And first thing that we can do is add a random selection. And for that, of course, we can use a random value, switch this one to Boolean, and plug this one here. And now we can control the number of windows, something like that. And in order to make things visible for us, I'm gonna do something here. I'm gonna add a material and choose a blue material. It's just nothing special, it's just a simple color principal BSDF. So let's take red material. That will be for our windows. And if we take the top here as a mask, we basically put the material only on the last face that was extruded inwards. So this way you can add lights to, you can make a light material here, and this will be for the buildings. And now we can have little windows. Awesome. So now that we did this, let's add a little bit more windows. This is too bare actually. So let's do something like this. Excellent. And let's say that we want to make sure that our windows don't start at the bottom. How can we do that? Well, we can add another mask. So let's say and we want to add another condition here. And this time, let's do a mask based on position. So I'm going to take the position. I can drag something out from here and say separate XYZ vector and plug it here. By the way, this is in this menu, vector menu. And then we can use the Z axis, meaning the height in our case, to do a comparison. So let's do compare, plug the result here in this Boolean, take the Z, plug it here, Control H to hide the unneeded sockets. And now this value will control when we start showing the windows. So if we do something like this, we can make sure that, as you can see, the bottom windows disappear. So let's make it like this, something like 0.05 to make it round. Excellent. So now we have our setup for the windows. It's time to move to the next point and add the antennas. And for the antennas, I kind of want to have a random number of antennas here on top of the building. So some buildings will have one, others will have two, others can have three, and something like that. And I want these antennas to have an interesting shape. It will help us play more with the extrude node. So at the top, I want them to change shape to be something like that, or maybe something like that. And I also want these sides on the top to use a different material that can be lithium. So you'll have like lithium antennas. That's the idea here. So in order to do this, I don't want to use this subdivided geometry. I want to branch out before we did that. So we branch out and we join things. So we will get something like this. I'm gonna push this one here. And right now we kind of, as you can see, we duplicated the geometry here. If I close this branch and open it, you can see it here. We have more geometry. So once I branch out, let's see. I want to have these antennas on top here. So I need to use a selection for the top face. And we will start from there. I want to delete everything that is not the top face. So let's do delete geometry. We have the top face here. So if we do this, we basically delete the top face and keep everything else, but we want quite the opposite. So let's do a Boolean math and switch this one to not. And now, as you can see, this is overlapping. it has no material, the white face. We kept the top face. Okay, excellent. That will be the first point. Now, because we want to do not instancing but extruding, and if we do, for example, now the extrude, so let's say I do geometry, mesh, extrude mesh, plug this one here. As you can see, we get one extrude here, and we can of course play with these, say, scale elements and do this like 0.5. We get one thing, but we want more than one, and we want to use extrude. So let's subdivide this mesh, plug it here and give it some subdivision. And right now we see nothing, but that's okay because we can fix that. So how can we fix that? Well, I want to extrude some of the faces. Right now we extruded all of them with a single value. That's why we get this. So let's say, for example, I take this one and I plug into it a random value for this extrude, and plug this value here and give it, let's say, something very small to something less. As you can see, we have everything extruded. Now it's obvious, but we don't want that. So we'll do the delete geometry trick again. So let's do geometry, delete geometry, plug this one here. And for a mask, this time we will use a random value like I showed you earlier at the beginning. So if we do this and we plug this one here, and let's switch this one to face because we want to delete based on the face, and switch this one to Boolean and plug it again. Now we can control the number of faces that get deleted by playing with this value. So now we can see we have a random number of antennas on each of this building. Of course, nothing stops us from using another random value for the thickness of this. So let's do like, I don't know, very nice variable thickness. And as you can see, looking close, some of them will be thicker, some of them will be thinner. That's basically what we wanted. So now that we did this, let's play with the tip. Let's add some details to the tip of these antennas. Let me push this one a little bit, duplicate this extrude node and plug it here. We want to use the top faces. Excellent. And now, as you can see, we have this extruding happening. And we want to control this extrusion. We want to have kind of like different heights, of course. And let's do something quite small this time. Maybe something like this. And as you can see, we get this extrusion. And if we put the scale elements after this one, and of course we use it only on the top face, as you can already see, we get this effect happening. So let's do a random value on this one as well. Plug this one here and say something like maybe 0.1. It will give us some pointiness. And if we do a big value above 1, we get something like this. So some of the buildings will have different type of antennas, as you can see. And that was the idea, to have some variation. Of course, you can play with these values to get something that suits your taste. But we will stop with this here. I'm gonna just add the materials now. Set a material, and let's say we want the yellow, and set another material and say we want the green. Why not? And the green will be the one that will come on these sides. I don't want the top this time, I want these sides. So how can we do that? Well, we can take this value and plug it here, and as you can see, we got the result. And this could be the glowy part. But I want to make sure that not all the antennas are glowing. So again, we can add to this mask by doing Boolean math and, meaning we have to fulfill two conditions. And the second condition, it will be, you guessed it, a Boolean value. So if we plug this one here, you can immediately see what is happening. Some of the fences will be lit, some of them will not. So now we can control just how many of these are getting lights on them, basically. Excellent. So that will be the part with the antennas. Excellent. Now that we did this, I want to save things and go to the next point, the background buildings. And for that, that's going to be interesting because I'm going to show you another way you can do these kind of things. We will do an instancing approach. So we have this joint geometry, and I want first a ground. And for that, I'm going to use a circle. Plug this circle here and give it a face and make this one quite a bit larger, like let's say 20. So now we get this huge playground. And having this, of course, you can give it a material. I'm just not going to bother right now. But I'm going to use this one to distribute some points that we can use. So let's say distribute points on faces. I'm going to plug this one here and plug the result here. And as you can see, we kind of have a lot of points here. And we will have a lot of fun here. I'm going to show you how you can mask these points in different ways. We will make sure that, because these points will be used to instance other buildings, we will do a mask to make sure that no buildings will be instanced near the ones that we created by the other method. And then we will make sure that at some point, something maybe like this, we stop instancing stuff. So basically we'll have a mask that will remove the points from here, and another mask that will remove the points from here, and a third mask that we will make sure to give some patterning to whatever is left here. So let's do that. Let's start with cutting out the center, and all these masks will be based on delete geometry. I played a little bit with the density and didn't get exactly the results that I wanted. So let me first increase this. As you can see, we kind of have a lot of points now. And if we do this delete geometry, we can get rid of some of them. So if we want to cut out the center, we can use the position. And of course, we will need to use a compare node. But this time we'll switch it to vector, plug this vector here, and plug this one here. And now we can say something like this. Let's put this on 2 and say everything that is less than this value of 2, I want to be deleted. And as you can see, we don't get the result that we want, because some of the position are on the negative side, some of them are on the plus side. So everything that is less than 2 will be deleted, but this is not exactly what we want. We would like to affect the position that are on the plus side, like here. So how can we do that? Well, we gotta get rid of the sign, because right now we have minus and plus, and we just want positive values. And there is a very useful function for that. It's absolute. That will basically remove the sign, and that's going to give us this result here. Don't mind that I don't mind that it's a square. Actually, I want it to be a square because I'm going to show you how to make a circular mask. But it's interesting to see how you can make a squared mask. So that will be our first mask. Let's do some random spots now. We will add to this mask. So again, if we want to combine masks, Boolean math, plug it here, but we don't want an AND now. We want a cutout if either of them is true. So that would mean or. This or that, not this and that. So we can again play with this position. We can duplicate or use the same node. The effect is exactly the same. And I'm gonna use like a noise texture this time. Take the position, plug it here, and then take this node, backspace on it to reset it, take the factor, plug it here, add this value here, and now we have something to play with. So let's switch this one to less than. And now we can play with this value to cut some of the points. And the scale to alter the pattern. So let's do something around like 100 maybe. And as you can see, we start to get some splotches here in our texture. So let's make like a 0.6. And we got some variation here. That will be the second mask. Of course, playing with the values, you can get different results. Playing with the textures, you get different results. But we want to just focus on the principles of it at hand. That's why I didn't do something really realistic. I just wanted to play with Extrude Node. And actually, I kind of like the cartoony look. Anyway, rambling aside, let's build the final mask. Let's cut out these outer parts to make sure that we remove this. And the reason why I did is there is a practical reason for that, is because when we go to a camera view, you don't want to instance everything, because if you go close like in the demo, you will actually not see the stuff that are on the edge here, but they will be rendered, and that's gonna be bad for your render times, and we don't want that. So let's do another mask. So if either of these is true, we cut the points, and again, either of this is true, we cut the points. So let's mask the outer edge. I'm gonna use this part, position and absolute, and I'm gonna take this node again, and this time I'm gonna do a greater than, because I want to use something that is greater than a certain value, let's say 6. But as you can see, nothing happens, and that's the cool trick, because right now we did until now we did a element wise comparing, meaning that we compared the output of this node and the position of every point on a per axis basis, and that gave us this square, as you can see here. But if we switch this one to another mode, as you can see, you can use different ways to evaluate the vector. So if we switch it to length, we get a circular mask that is controlled by this. So you can play with these values as you see fit. Being a length, you can actually play with any of the values and get the same result. So this is how you can do this different type of masks that you can use to create awesome effects. But it's time to add the buildings after all this masking. But before I do this, I want to add another control that will be a good way to use another fairly new node. This one, merge by distance. So this way you can cut some of the points out without using pause. Or if you go too far, you will get something closer to what the Poisson gives you, but I don't want to go that far. So let's say like 0.1 maybe. That will control the distance between buildings, 0.15. Great. Another good tip for you. How can you thin out this without using Poisson, meaning keeping more of the randomness that you see here? So the different method that we are going to use now, it's not instancing, it's not extruding, it's instancing actually. So let's do an instance on these points, and what we want to instance will be a cube. This is another way you can get buildings. So let's do the cube, and as you can see we get this result. Let's put some material on that. Material, set material, plug this one here, choose something like the green material, and as you can see everything is humongous. So let's change that. Let's put this one to 0.1 for example, and we get this. But if we switch to a side view, you will see something. These are halfway through the plane, and that's because the origin of this cube that we created is in the center. But we want to move the cube up, so the origin will be here at the bottom. And this is the moment where I'm going to show you how you can do this procedurally. Let's take a value. I'm going to take this value that we used here, 0.1, plug it here. We are happy with uniform scaling for now. And we want to offset the position of this cube that we are using as an instance. And for that, we will use the set position. And if we plug this one here to the offset, we will offset it in all the axes, and this is not what we want. We actually want a vector, combine x, y, z, and we want to push things on the z value, as you can see here. So we want to push them here to get them to the red line in a procedural manner. So if we push this one here, as you can see, we push them too far because we have the origin at the center of the cube, meaning half the distance. So we have to push them half the distance up. So in order to do that, we will plug a math node, switch it to divide, and we will divide it by 2. So now, no matter how much we play with the scale, the buildings will be basically grounded. And that's important because we will play with the scale after we instance. And that means that we don't want buildings to start to grow in the ground. We just want them to grow up. Yeah, I think it's interesting. Anyway, it was a joke about growing up. Anyway, we did the instancing part. Let's play with the scale now. We want to make some of the buildings taller, some of them shorter, and we want to affect the width and the width of the buildings, but not in a such a great way like we want to push for the height. So let's switch this random value to a vector, and now we can play with these values. So I want to keep a minimum of 1 of the height, and I want some of the buildings to be quite tall, so something like this. And as for the width of them, let's start with something like small and make some of them like maybe width, have a lot more width. So we kind of get this result. Awesome. I want to add now the windows for this setup, but I want to have less details. I don't want to do extrude and stuff. I want this to be more resource friendly. And in order to get windows, we can use also the assign material trick, but we will need some more geometry for the base instance. So I add something like this. 32 maybe is too much. Let's do 16 for this demo. You can add more to that on the end. So let's do the material thing. We added the green material for the buildings, and we will use the red materials for the windows. And now it's time to build a mask. First mask that I want to build, it's gonna be a random value. Switch to Boolean and plugged here. So as you can see, we immediately get something going on. And if we put a small value, we get a lot less windows, as you can see here. But as you can see, we get them on top, and I don't want that. So we will add something to this math. So we want this to be true, and we want to cut out the top of the buildings. So if we talk about the top, we talk about the position. So let's separate this vector, separate XYZ vector. And now we can use a compare node. Compare, by the way, you can also do something like this, compare, and say equal. Okay, equal. I tend to use the menus because I want you guys to see where the nodes are, but it can be a lot faster doing this drag and search thing. So now we can do a compare, and we want to compare on the z value, and we calculated this half of the building, and that's going to be useful for us now. So you can use it from here. Of course, it's not going to be quite precise because some of the buildings will be a lot less high. So you can think about creating a mask based on the output from here. You can do something like attribute statistic. That came to my mind right now. I'm not gonna go this route. I don't want to make this any longer than it has to be. But you can do this more precise. I'm gonna settle for this. And now this epsilon will basically give you a control over the height and the length of this. So you get rid of the stuff on top if you want, something like this maybe. And it's worked quite nicely for the smaller buildings as well. So I'll do that. Excellent. Now that we did this, it's kind of yeah, everything I wanted to show you in this tutorial. It was a lengthy ride again, so thank you to staying till the end. Thank you very much for watching this video. If you find this content valuable, please like, subscribe. That's gonna help this channel. Also, you can decide to purchase the project file from Gumroad as well. In the hope that you find this useful, I say to you, happy blending and have a nice day.